Okay, this is a short video on Lesson 9, trying to help people with the concepts and understanding the question. I'm going to be using the exercises as my basic springboard here, so if you want to turn to that, you can. That may be a good idea. Okay, conditional probability in the multiplication rule. Let me just take something that's very simple. If I had three shirts in the closet, three shirts, and I had two pants, okay? Two pants, okay? What would be the probability of picking a particular shirt and particular pants? Well, let's see. Wouldn't I have six outfits altogether? But for the number of pants, a particular pants would be one out of three, and one out of three for the shirts, and for the pants would be one out of two. Now, we already know we're going to have six possible outfits. So if I'm going to pick one particular one, it's going to be one out of six. How can I get one out of six with 1 over 3 and 1 over 2? The only way is to multiply. Okay, this is called the multiplication rule. Now, we're assuming the events are independent, okay? Now, if the events are independent, then you just have this basic rule. Here's the rule. The probability of A and B happening together, in other words, a particular shirt and a particular pants, is going to be the probability of A times the probability of B. Okay, that is it. Now, let's try another example. Heads. Okay, heads. What's the probability of getting two heads? Well, there's four possibilities altogether. There's four possibilities altogether, but let's just figure this out using this rule. The probability of the first head is 1 out of 2. The probability of getting a head the second time is 1 out of 2. Now, obviously, we're not adding these. We're multiplying these two numbers, these two fractional numbers. And that probability would be 1 out of 4, or 0.25. Okay, so that should make sense. The next thing we need to do is we need to talk about the complement. The complement. The complement of a probability is 1 minus. The weatherman says there's a 30% chance of rain, but you ask, what's the percent chance of not rain? That would be what? 70%, or 1 minus 30%. Now, what if I had 3 coins, and I want to know what's the probability of getting at least one head? Probability of at least one head. Okay, well, now we can list out all of the possibilities. We could have heads, tails, heads. We could have tails, tails, heads. Now, we're going to be doing this for a while, but let's see if we can go back and understand the question. The probability of at least one head. Can I have one head? Yes. Can I have two heads? Yes. Can I have three heads? So this is really what it's asking. What's the probability of having one head, or two head, or three heads? Now, there's only one other possibility, and that's no heads. Okay? Well, since all of these probabilities have to add up together to be one, I could find the probability of this group by just finding the probability of no heads and then using the idea of a complement. So let's do this. What's the probability of no heads? Okay. Well, that would mean all tails, right? What's the probability of getting tail on the first one? 1 out of 2. Second one, 1 out of 2. Third one, 1 out of 2. And what is that? That's 1 out of 8. That's the probability of getting tails, tails, tails. Well, what is the complement of 1 out of 8? It would be 1 minus 1 over 8, or 7 out of 8. Okay, and this is what I'm looking for. That's the idea of a complement, especially in working these kinds of problems. Hope that helped you. The other thing that we need to talk about is this idea of a conditional. Now, a conditional is when events are not independent. So what's the probability of you enrolling in E-Corps and getting an A out of this class? Well, first of all, we got to figure out what's the probability you getting an E-Corps, and then the probability of getting in the class. So there is a matter of a condition. It'd probably be a good idea to just simply say, given you enrolled, what's the probability of getting an A? There's a little formula that you got to be familiar with. The probability of B given A happening is equal to the probability of both over the probability of A. All right, now try to keep that formula clear in your mind. And if you will do one more thing, and I call this common sense, just a very informal way of working these problems. If you will work both of these together, I think you'll get this lesson. Let's do some problems. All right, let A and B be events, and they give you all this information here, okay? And notice they give this to you. Well, since they gave that to you, the probability of B given A, then you know this is conditional probability. We're just going to write the little formula, which I just wrote. That's okay. Okay, remember? I just wrote that. Okay, well, what do we know? They told you the probability of A is 0.66. And they told you the probability of B was 0.45. And they told you the probability of B given A is 0.62. Okay. They want to know what's the probability of A and B. Okay, so what are we going to have to do? We're going to have to multiply, we're going to have to cross multiply and multiply 0.66 by 0.62, which is 0.4092. All right, let A and B be independent events. Well, if they're independent, then you just multiply them together, 0.41 times 0.55. Okay, that's how you do the second one. Now, let's take a look at this chart, okay? Look at question number 3. Before we look at question number 3, what we need to do is we need to go through here. We need to add up all of the rows and all of the columns, okay? Okay, I did that. Now, how about number 3? What's the probability that a randomly selected child will have blonde and wavy hair? Blonde, and wavy. See? 5. 5 out of what? 5 out of the total, which is 215. Look at number 4. What's the probability that a randomly selected child will have straight hair given that it is brown? That is the key to this problem, given that it is brown. So we're going to look over here. Here's brown. There's 100 that are brown. What's straight hair? That's 80. So that's going to be 80 over 100, which is going to reduce. Number 5. What's the probability that a randomly selected child will have black hair given that it is wavy? Now, here's wavy, okay? There are how many? 43. But how many are black? 15. So 15 out of 43. 6. Are the events of having brown hair and wavy hair independent? In other words, by someone having brown hair, does it have to be one way or the other? No, okay? I mean, they're not related to each other, so they are independent. Get that confused sometimes. 7. Would it be unusual for a randomly selected child to have straight hair given that it's red? Okay, here's red hair. To have straight hair, that's 12 out of 15. And remember, it's got to be less than 0.05 to be unusual. So this is, no, it's not unusual. Okay, among those who go to the mall, the probability of being approached by someone selling them something at a kiosk is 0.32. Of those approached, the problem of making a purchase at the kiosk is 0.11. Find the probability of both, okay? Find the probability of both. Now these are independent probabilities, so you're simply just going to multiply the two of them together for number 11. And I think you get an answer for that, which is like 0.032. A fast food restaurant, each large drink comes with a peeled off sticker on its side. The probability that any given sticker is a winner is 0.24. If a customer purchased 3 drinks, what's the probability that all 3 are winners? Well, let's see. What's the probability that that guy's a winner? What's the probability that guy's a winner? What's the probability that guy's a winner? In theory, you getting this a winner does not affect your next cup, okay? That's 0.24 cubed, which is something along the lines 0.0138. Okay, on any given occasion, a certain snack machine will fail to work properly with a probability of 0.08. Now, no one likes it when the machine doesn't work, okay? So the probability of failure is 0.08. 5 customers come to make a single drink purchase. 1, 2, 3, 4, 5. What's the probability that will fail with at least one of the customer? At least one. It could fail with 1, it could fail with 2, it could fail with 3, it could fail with 4, it could fail with all 5. Now, the only thing you didn't take into account was failing it with none of them. And if we could just figure that out, then we could do the complement. Well, for it not to fail, if failure is 0.08, then that would be 0.92. And so 0.92 to the 5th would be it not failing with all of them. So just do 1 minus that, and you should get 0.34, 0.3409. Okay, see how that works out. Jade is a heavy sleeper. To make sure that he wakes up in time for class, he uses 3 alarm clocks, each set 5 minutes apart. The probability that any alarm clock works is 0.7. 0.7. Assuming the alarms are independent of each other, what's the probability at least one of the alarm clocks will wake him up? Okay, that is what you call a very heavy sleeper, okay? Very heavy, okay? So anyway, what we're going to do is at least one of them, well, that means 1, 2, or 3 wake him up. Again, let's find the probability that none would wake him up. 0.3, 0.3, 0.3, which is 0.027. Okay, so that's the probability that none would wake him up, and the complement 1 minus 0.027. See if you can do this in your head. 0.973. Okay, see how that works out. Okay, let's see if this helps you in understanding those questions on lesson 9 with conditional probability. Okay?